be another one of them dark videos. It is Mike Levin on Friday, November, I want to say 19th, 2021. Coming up on 7 p.m. and I'm on the drive to pick up my kid. There's stuff I want to talk about. So much. Personal front, professional front. But I think I'm gonna start out with the easy pickings, which right now are on the professional front on two fronts. The first is through circumstances being what they are, life, I am venturing into full stack web development. Something I have generally avoided like the plague, because in my ongoing trimming the fat of the tech liability in my life, I found that everything got easier if you kind of try and focus in on Python inside a text editor that'll be with you for your entire life, VI/VIM, more of a telepathic API between humans and text really than a text editor. And once I understood what it was, it very much appealed to me, and there is a unholy union between Python and Vim, and it got me very excited. And I've basically been able to tackle any project that came my way using a certain limited set of methodologies, which abided by the 80-20 rule. So with the first 20% of the technology you could take up, the effort you might be willing to put in, you get back 80% of the benefit of your effort early on, 20% of the way into the project. So you front load your successes. So with minimal effort, you get maximum return, and you're working with short iterative cycles, so you can rinse and repeat a lot and have a forever improving whatever. And so getting better at Vim, getting better at Python, the 10-year march towards mastery, which I blew past about a year ago. Malcolm Gladwell has it pretty correct, I believe, with 10 years or 10,000 hours for things to really become second nature. And so I'm dealing with, during that time period, Python, I went from Python 2.5, which I really have my first memories of being Python version aware, to 2.6 quickly, where it became a very stable, well-accepted version. And the equivalent of what more people remember recently as Python 3.6. That was a stable, well-accepted version. There's something about the 0.6 versions in the Python world. Not that there have been too many, with them being only version 3.10/3.11 right now. So the 0.6 versions have been very big, and most of my 10 years of cutting my teeth on Python have been between 2.6 and 3.6. By the time 3.6 had its run, it's like, okay, I got this Python thing down really well, and really only within that Python thing, the first 20% that gives me 80% of the benefit, because there's so much in Python. I'm still working my way through some of the more obscure package collections in the standard library, like the collections package. And of course, all the data science stuff under scikit-learn and applying models and stuff, that's all still new territory for me. So even having achieved muscle memory mastery with Python, because we really should separate the types of masteries that are out there to be won. But having won the muscle memory mastery of Python and Vim together, I feel I can pretty much tackle any problem and have a fairly competent solution. You don't have to look to other technologies often, And when you do, it's usually C, some variety of C that works with a Python C API, so that you can get, full breakneck C, compiled C optimized speed from some bottleneck in your Python code. So Python was already born having a heavy C bias, a bias towards C as its companion language. Now, the truth is, any language that has that API client library, developed for it could just as well be a API compatible language with Python. It's just that C is the one that shipped with Python from the beginning, and C is what operating systems and drivers and everything optimized is really written from these days. Ever since Unix / Linux became the dominant operating system of back-end systems, computers in business. Aside from the desktops and laptops people actually worked on. It's such a weird split between what people call back-end and what people call front-end or consumer-facing technology in tech. There used to be a really clear divide between the two, and the line is getting increasingly blurred because consumer-level tech is more than capable of running things in the back-end way, in the way that they run in colo server farm centers or whatever you want to call them. But for 24/7 reliability, things get put into a kind of server mode. And that means there's not a lot of tolerance for memory leaks, for things that were designed to be run once, for things that statefulness is a kind of voodoo science of the order you run things in a Jupyter notebook. It's a hard point to make, but deterministic is a word that pops into my mind. When you get things onto a server to be run in a non-attended automated fashion, usually servicing people elsewhere, you try and stabilize things so you don't have to think about it a lot. You just want it always running. You don't want it getting bogged down over time, such as our desktops do. We keep every program we ran through the week still open and tabs accumulating in our browser, and then along comes an occasional poorly written thing that gobbles up some resources of your computer and doesn't give it back. So, there was a time when Windows had to be rebooted every day. It was unimaginable to go on a 2 or 3 day run without rebooting Windows. That's unacceptable for server-based software. That's why there was such a split back in those days between, say, Windows 95, which was consumer-facing, and Windows 2000, which was based on NT. Really different core underlying code for the servers. In fact, there was a, a high point in Windows where Windows 95 came along on the consumer-facing stuff, and besides the Trojan horse and virus-plagued landscape that resulted in, it seemed to get multitasking down really well and got the ugliness of the Windows 3.1, predecessor out of it. Windows 95 was pretty in multitasking, and it looked a lot like, say, the Amiga computer and other expectations that were made prior by non-mainstream Intel Windows PC-based computers. People knew it could be better. The Mac would have been the example. However, the Mac kind of took a nosedive during those Sqlite days. Is it John Sqlite? I forget the name, but the PepsiCo president of Apple, when Steve Jobs was ousted, they made the Mac Color and 10 times more expensive. Ooh, it was really no big deal. It was the computers I learned Quark Express on when I was in college, the Sqlite generation of Color Macs, and it was nothing to covet. There were other computers out at the time, like an Amiga with a video toaster, that was worth coveting. And a lot of really quirky, I guess they called it workstation computers of the days. Apollo, which I think which was bought by HP, but HP had their own entries, and then CGI and MIPS. There was a whole range of them, and they were based on bad boy rebel technology, not even Unix based at this point. So there might have been some Lisp based hardware there that, was biased towards Lisp as a, programming language, just like the Unix platform is biased towards C and, x86 style hardware. A lot of it was written for the mainstream hardware that was out at the time, and so that became mega popular. The role of yesterday's Apollo and SGI workstations is today played by common, even cheap laptops. So the x86 hardware from the Intel PC clone lineage really seemed to have won, hands down. A lot of other of the rebel technologies that kind of sort of mainstreamed at that time, like the Motorola 68000, which the Macs were based on, that split off and became RISC. Part of it was owned by IBM. There was another company that broke off. I think it became the Cell processor, and it's still out there here and there. But of course, the surprise to most people was what came up from mobile, what came up from the lower end. Of course, the ARM processors that have, always been around. I mean, I was infatuated by the ARM processors over the years and bought, servers like the Shiva plug. Go Google that. That was a quirky little piece of hardware. And there were different, Raspberry Pi being the main one, but there were different, component-like boards. Marvel had one that really gave you Linux on a different kind of hardware. So, the point I was making here, what was I making? Generic technology and the relationship to the hardware. I've churned through a lot of tech. I have attempted to make my main work platform many different language, hardware combinations over the years. I was a TCL person, Tickle, for a while. It was a good list processor. A lot of these things are list processors. I tried Perl on and off through the years. So I go back to the original, P languages of the LAMP platform: Linux, Apache, MySQL, and Perl, PHP, or Python. Of course, recently I've gone gung-ho Python, but that shows how long Python has really been around as one of the primary web languages. Django goes back to, I think, around 2005, and before that there are these things like Clone and Zope that I believe were Python-based that go back even older. So, Python is no stranger to the web. I was talking to a coworker today who was like, yeah, Python, but, it's not as strong on the web, right? And I set him straight. I'm like, it's because Python is zero drama. It doesn't have the drama and the story surrounding it that, say, Node.js has. And all these JavaScript platforms like React and Vue that people are so infatuated these days with. It's all spell casting of different sorts, and there are some very flashy, sexy spells being cast on the React and Vue and Node.js combination platforms. But there's a lot of very unsexy stories, that aren't told because they're Python based and everything just works. Where's the story of Instagram and Reddit? It's because the UIs are boring, I suppose. But Python is always a contender on the web as a primary, development and runtime platform. There in the background, just not bringing much attention to itself. The story is not quite the same on mobile, but before I go into that story of Python, I go back to picking out your tech, your personal tech stack that you can achieve mastery with. So the real problem is that same 10 years, 10,000 hours that it takes to become a master at some given thing is about the same amount of time for that thing to go completely obsolete in tech. You know? The Angular platform, the over-engineered Angular platform comes to mind. Now, I guess, you know, if you were an Angular fan and you were bitter about React, you could wait for Vue. One of my other coworkers pointed out to me how Vue was like a second coming of Angular, fixing most of that over-engineering issues of the mean stack, because the mean stack really was mean. First, it starts with MongoDB. I mean, really. Even though I even fancied that as part of my primary development stack for a while, I got Mongo fatigue. Everything is so unusual and different in Mongo. I'm like, you know, 3 servers, really, just to get started? Oh, it can be done with 1 server. Well, you know, instead of opening with gotchas, why not just open with everything just works the way you expect? And so that's what led me to using the Python dictionary API for NoSQL work, back-ended by Sqlite, which is included with a standard library. So unfortunately, you can't interact with Sqlite as if it were a key-value pair database or a NoSQL database without some other, we call it WORM, object relational mapping software involved. And most of this thinking brings you down paths that lead you to SQL Alchemy, maybe TinyDB, but one way or another, a more robust than NoSQL ORM, a SQL ORM, something where you don't have to learn the particular vendor implementation of SQL, but you do have to learn a custom ORM, a Python-specific package-specific API, object relational map, way of interacting with tables and their indexes and keys that is a very non-portable knowledge. Not all worms are the same. You learn SQL Alchemy, you're a SQL Alchemy person. I did not like that. So I was like, what I really want is persistence in Python dictionaries. If you just give me persistent Python dictionaries, then I get so very much. And so I looked at the standard library and I said to myself, what that is it's the pickle technology, the serialization of any object in memory into a file object that can be reserialized, serialization of that object off the drive back into an object in memory. So you can reacquire state from a, you know, previously run of Python, and you can get, say, all your object values back. So if you had run a very expensive function that went out to external resources, maybe did a crawl, maybe went to paid APIs, pulled back some data, populated some object in memory locally, without all the overhead of a database, how can I have that again later? Well, the Python stock answer is pickling. And while everyone will point out, oh, pickling is dangerous because execution of arbitrary code in that pickle, if you only ever unpickle things you yourself pickled, the danger goes away. The danger is when you unpickle things from the wild. It's the running of arbitrary code. So as long as you use it for yourself, there's no problem. So pickling is doing that for a single object. Shelving it is doing it for a bunch of them. So shelves are the Python standard library answer to NoSQL. And so I started using shelves, the shelve API, to have persistent Python dictionaries, key value pairs. Start using SQL. No, it's not even using SQL. There's no SQL in the picture. Start using Python as if it's a NoSQL database with NoSQL in the picture. Now, that was good for a few years until I started doing larger and larger jobs and started doing things at scale and started having large objects being shoved into those shelves. well then that's where Python's speed really rears its ugly head. However, shelves are written, they are not optimized. So I was like, Sqlite comes as part of the standard library, and that's one of those magically optimized components, super optimized in C over the years, recycling the same optimized Sqlite C code as everyone else that uses. It's one of the great gifts in tech. It's a lot like the regular expression library that was in Perl that everyone has been lifting. Essentially, the Perl regular expression library is the one that became the P in the pool of tech. A great gift. It's in there. It's never coming out. Everyone has regular expressions now baked into their products. Sqlite is similar. You have a full-fledged SQL database, optimized, high performance, maybe not multi-threaded, maybe it doesn't have all the bells and whistles of your more enterprise level versions of this, which would include MySQL, Redis, Postgres. There's a whole host of them. Postgres is a lot of people's favorites these days, but if you're not using Postgres, which can also achieve NoSQL results as well as the NoSQL database. Sub-reference stories there. Maybe I'll come back to these later. And the difference between ACID and BASIC. There's a lot to this story. But I basically wanted high-performance, persistent Python dictionaries. So if I had a Python dict, I wanted to be able to pickle it and unpickle it fast. And in fact, I wanted to be able to pickle and unpickle tens or hundreds or thousands or tens of thousands or hundreds of thousands fast. Enter SQLite. Enter one Python packaging index, one pip install that you have to do. And that happens to be SQLite dict. SQLite-dict. Pip install SQLite dict. And then you can import that. And I have a special import that I do, that I like, because they have that capitalization ambiguity. I hate capitalization ambiguity when you're starting out with an already all caps acronym like SQL, Structured Query Language, and then you put it into something that's going to be camel case per the Python, per non-Python language conventions, and somehow managed to seep into this part of the process of naming Python packages. So somehow a lot of packages that you import have camel case, or some version of camel case where it's lowercase first or uppercase first. Might be Hungarian case when it starts out with an uppercase, but when it starts out with lowercase, it's usually camel case. And that's usually what you see in Python, that I think inherited a lot from Java and JavaScript and C. Camel case is real popular there, and APIs especially. So I import from all lowercase SQLite dict in camel case as SQL dict. I played around with abbreviating it to SQLite, but that doesn't really say a lot about what it is. What you really want to do is have a dict, a Python dict object, back-ended by persistent high-performance SQL. So, SQL dict, all lowercase, and it works wonderfully with a Python context manager, which is what you see normally as with open as. If you see with open as, you know you're looking at the context manager. What's so special about the context manager? Well, lots of things in the Python ecosystem are actually back-ended by things outside the Python ecosystem. Specifically databases like SQLite. Specifically databases and file operations, reading and writing from files, which are just another form of database. it almost always comes back to database. It's, it could be anything, but when you're opening file locks and you're doing interaction with stuff, and then you have to close those file locks, and then you have to free up those resources, that's usually an external system, and it's usually some variation on database. So, in the olden days, you used to have to explicitly open and then explicitly close the connections to those external things. You had to say, make the connection, use the data, perhaps recycle the pointers. Oftentimes it's called cursors in this world. Curses. There's a lot of reasons to curse them. For various media-related performance issues, cursors tend to be read-only and forward-only. Sometimes you hear it referred to as fire hose mode. Well, once you define the data you're trying to read, if the system can put a pointer somewhere in the data and say, read forward from here, until you reach the end, then you've got a really high performance system. And so there's a lot of striving for that really fast read once, forward only, and the media might not even be read off of the media might not even be read up front. It might be deferring the reading of the actual media for conservation of memory reasons until you actually need it. This is where the forward only and read onlyness of a lot of this stuff comes from. You can actually picture some sort of read-write head, like a needle on vinyl, only going in one direction because the physical media is conducive to that, and that's where you get the best performance. So, all the details that make that work, Python has very little business knowing. But the packages that Python is importing to interact with these types of things does in fact know all the details. And you used to have to open and then close at the end and do whatever other housekeeping you needed to do along the way. And it varied from database to database. And someone said, I forget, there's probably particular names. It's people like Guido or the other contributors to the standard library, the core developers, I think they call them. Raymond Hediger is one of the more influential ones, who did name to tuples, by the way. I know I have some connection between some of the core developers out there and the parts of Python, the interesting little bits of Python that they did, because those interesting bits sometimes often have a lot of personality that reflects the personality of the core developers, thumbing their nose at the world saying, I'll eval when I want to. And somewhere in there, someone said, well, it's always an open, and it's always this, cleanup work at the end. Why not just unify that under one API? We'll call it the context manager. We'll use the with keyword because we haven't used it anywhere else yet. So if you open a code block with, and we need something for it to open. So let's make a program called open, make it a very primary, always there. No imports are necessary for open. Give it the capabilities of some file system awareness, so you can open files directly out of the directory you're in. So if you ever wanted to open stuff, you don't even need to import pathlib. You don't even need to import Python libraries for interacting with the file system. You don't need to import OS. You just, with open local file name, that file is open. And there's a comma parameter. I think you can open it as read-only, or you can open it as binary, or something like that. There's some parameters on the open you can do. But after the termination of the open, after the close parenthesis of the open, you still can do one more thing, and that's as. So it's with open because it's some file system specific path or something. but you don't want to refer to that ugliness over and over, so you give it a nickname, you give it a handle, you give it a variable name right there. So it's with open as. But where open is normally used, I use SQLdict. So with SQLdict as, and instead of all these things like FH that I've used in the past for file handle, or I've often used handle, all lowercase spelled out, because it so accurately represents what it is. It's a handle to something on the outside, you know. You want to invoke this concept of a physical connection to a physical thing, because there probably is a physical connection to a physical thing going on there with that with open as. So instead of the handle or the FH, I use DB. So my new pattern, almost everywhere, almost every project I do now, almost every Python notebook or .py file I generate, somewhere in there has import SQLite dict. Oh no, wait, let me correct that. It's from SQLite dict, import SQLite dict in camel case as SQLdict, all lowercase, no underscore. So now I can have the recurring pattern with SQLdict file path as DB, colon. You indent your standard Python amount. But that is a magical place. That is the context that is being managed. That connection is open to whatever that media is from the with SQLdict file name as DB, colon. That database connection is made. You have a connection to SQLite. And the API that you use to interact with it is the standard Python dict API. In other words, DB with the square brackets coming after it, with any name as a key, equals any value from Python, will result in a serialized version of that anything. In other words, all the pickling is built in, so you could drop HTTP request response objects, right? So you can drop response objects from the request package or the HTTPX package directly in as a SQLite value. It's actually becoming a cell value, and I've inspected the table directly through the standard SQL, raw string API. That's an API too. SQL is an API, and every vendor implementation has its customizations to the SQL API, which is part of what makes it such a mess. However, because SQLite is P in the pool of tech, it's actually worth learning the raw SQL for SQLite. Contrary to most of my types of thinking, I would stay away from the vendor-specific implementation languages that underlie things, and go through the next most popular API simplifying library up. You want to do it. You don't want to speak in the dev protocols to Chrome. You want to speak in JavaScript Puppeteer protocols to Chrome to automate it. So even as reprehensible as that next API level might be as a JavaScript node library, it is less irreprehensible than dealing in whatever native language protocol is built into the device you're trying to talk to. Because whatever knowledge you gain there is going to be obsolete in a year, 2 years, 5 years, even 10 years. It's too short of an obsolescence cycle, with a few rare exceptions. And one should, if one wants timelessness, obsolescence, resistance to obsolescence over time spans of, let's say, 15 years. Because in 10 years, it's that one Malcolm Gladwell unit of mastery. So by 15 years, everything has collapsed around you, if you've made the wrong decisions, you might still be looking pretty at being a skilled Ruby developer at the tail end of the Ruby cycle, a skilled .ASP developer, ASP Classic, at the tail end of the active server page cycle, a master PHP developer at the tail end of the PHP popularity cycle. What we are engaged in now, really, oh, and I have my fan on, boy, that audio. What we're engaged in now is the peak, the middle, not the tail end, of the Node.js plus JavaScript library du jour cycle, popularity cycle. It seems so game-changing because front-end developers who got used to programming in JavaScript for their stupid browser tricks, very important for user experience stuff, could use those same set of, conveniently non-blocking I/O tricks on the server. Enter the term and the concept of full web stack developer. One language to rule them all. Very unification oriented, very popular syntax oriented, because although, it's not anything like C or Java, JavaScript uses the same curly brackets, and so the syntax feels familiar to the dominant comp-sci blessed languages. And because browsers become so darn important, and because Google threw its hat into the ring with a Chrome browser and faster JavaScript rendering with the V8 engine, and because browser wars kicked in again, JavaScript mainstreamed. I guess it was inevitable. It was not against all odds. It was because it could be no other way. So you can always polish a turd, and you can always make that turd very appealing, but that does not change the fact it's a polished turd. And I've been with JavaScript the whole time. I've seen these ECMA pushes of these development cycles. I have to keep reminding myself of the syntax of a anonymous arrow function. Not that I like the Python lambda syntax much better. However, you start out by creating a anonymous arrow function as your first step these days in doing a lot of Python work. I mean, just a lot of JavaScript work. There's a Freudian slip. Yeah, the Python work used to start out with this equally arbitrary and baffling and annoying, if name equals underscore main, if double underscore name in quotes as a string equals, no, if underscore main, oh my God, main underscore name. It's even tough to get it right in recollection. But it was an awful, awful part of the Python key patterns, and it really still is. So Python is not free of these things that I like to bust on JavaScript for. But the necessity and mental gymnastics required to understand JavaScript arrow functions is enough to turn me away from JavaScript. So the equivalent in Python is not really necessary. You don't need lambdas. They're not a core, they are a core part of the language, but life without lambdas would not be too terrible. Life without anonymous arrow functions in JavaScript at this point would be unthinkable. So you are forced into this odd, anonymous, asynchronous capable syntax that not only has the curly brackets that I am opposed to, that have arbitrary positioning, it has this equals greater than symbol, which I know it's not used by anything else. However, it is very similar to, greater than or equal to. You just change the order of them and you have a comparison operator. So, okay, so I can get over that. I can train my brain to see it. But then there is the open-close parentheses that have to go around the function, and then the similar open-close parentheses that are necessary to call a function. So what you're really doing is open-close parenthesis to define function, open-close parenthesis to send arguments and parameter arguments into that function. So you should expect to see that double open-close parenthesis as a pattern. And somewhere in there, there's the equals greater than that tells what things are going to be named and how values get sent between things. It is challenging, to say the least, for my brain. It's overhead. Now again, Python is not without its overhead, but Python's overhead and the mental gymnastics you need to do for your muscle memory. Okay, so here's the thing. The goal here is to stop thinking and to start working on automatic. This is also why your first language is special. And there was a meme, before memes, there was a meme that the basic programming language will drive you insane, or is the, current basis for psychosis or something along those lines. And that it permanently damages your mind against learning programming properly after that. And there was this big debate that raged. I don't even remember when this was. It must have been, late 90s, early 2000s at the latest. And, that really resonated with me deeply because, I learned on BASIC first. And then I switched to other languages. I think Rex. AREX. I did the Amiga version of Rex, ported by a friend of mine, Michael Sin. So my first sigh of relief going, oh, this is a good language. I understand what's going on here. It's good design. Inter-process communication goes smoothly. I can work. I had this aha moment of I can work with this. It was AREX on the Amiga. And I had done a bunch of other languages on the Amiga leading up to that. That just never gave me that feeling. So I very much, appreciate when a language suits your vibe. That's what's going on here. Certain people have a capacity for an ability to just breeze past the overhead, the fatigue-causing overhead that I get with curly bracket or curly braces issues every time. The thing being that they're necessary everywhere. That's being loosened up a little bit, right? So JavaScript, I think, is taking away the necessity to use the curly brackets, just like semicolons were optional, but good form requires semicolons. People do it all the time in JavaScript. They're semicolon Nazis. So I don't know how it's going to play out with the removal of curly brackets in JavaScript, but to my mind, it's just more ambiguity. Are they allowed there? Are you not use them there? It shouldn't be part of it in the first place, which is the way it is in Python. So with curly brackets, one of the curly brackets opens the definition of a function, and the other curly bracket closes the definition of that function. Okay, so what's wrong with that? What's wrong with that is that the positioning of that one that closes the function, the end of the code block, is arbitrary. You can put it anywhere. It could all be on one line if you want. And now if it was on one line, it should be something more like an anonymous one-off function, which is the way it was architected in Python. If you want it on one line, you don't need to give the function a name. You don't need anything enclosing it. You know, it's just lambda x colon x equals x plus 1. And that's a lambda function. That's how you don't name a function in Python. In JavaScript, you open close parenthesis and then equals greater than, and then a curly braces open and curly braces closed. I think that's an anonymous function. There's some other details there, because now if you want to invoke that function with a parameter, you need an open parenthesis after the closed curly braces. And so to get rid of ambiguity, put an extra set of parentheses on the outside of the curly braces, especially if you need an async for an asynchronous. Well, anyway, it gets very, very confusing. And I have to relearn it every time. It is not sticking. And again, I tell you, I've been with JavaScript since the very early days. I tried using, for JavaScript on the server is not new. Yeah, I say in several videos, it goes back to Netscape. Netscape used it in the browser. Netscape browser, one of the two programming languages, was JavaScript in the browser, and on the server, Netscape had Enterprise Server, something like that. There was a Netscape server product which had JavaScript on the server. Yeah, JavaScript on the server. And then along comes Active Server Page from Microsoft to kill all that sort of stuff with its anti-competitive practices. And they made VBScript their primary language of Active Server Page. However, it did work with JavaScript as well. JavaScript was a valid primary Active Server Page language. No plugins, you could just start coding in it in JavaScript, and it would work on old-fashioned Microsoft .asp style servers. It might have been JSP, Active Server Page, ASP, JSP. I think they were JSP files. There's probably quite a lot of JSP files out there too. And then when that died off, there were attempts to do with Firefox, the Firefox JavaScript, engine, what ended up being done with Node.js and the Google V8 engine, and that is to extract it and put it on the server. And in those days, that was called the Rhino engine. The V8 engine on the Google side was the Rhino engine on the Mozilla Firefox side. And when you pull out that Mozilla Firefox thing and turn it into a server component, that was called Helma, Helma. So I actually even set up a Helma server to cut my teeth. And this was like months before the Node.js, announcement. So I actually put JavaScript to the side with, oh my God, a hairline timing where I would have become an early Node.js JavaScript developer in the very early days. I think I would have jumped on that bandwagon, gotten over my language aversion, determined to commit JavaScript to muscle memory. I think I would have done that. And it just didn't happen because I was just a little bit ahead of Node.js in my research, and Helma is what I found. JavaScript on the server, right? You Google that today. It's unimaginable that it doesn't lead to Node.js, but there was a time where it did not lead to Node.js because Node.js didn't exist. It led to Helma. So, just merely on the basis of it not being mainstream enough, I couldn't rebase myself on a kooky fringe platform. I put JavaScript on the server to the side and said, okay, let me see what else there is. And then I followed a much more pragmatic approach where instead of trying to get one language to rule them all, because that was very appealing to me, I said, well, let me follow the APIs. Let me see where the path of least resistance to get work done really resides. Oh, wait, Google always offers their client libraries in Java plus Python? What's going on here? And C# might be another one, so that's .NET. So they offer it in Java, .NET, and Python. Where's the Ruby one? Ruby on Rails is so popular. No, Google doesn't offer a client library for Ruby. So even during those days when Ruby was a close competitor, because of Rails and the framework and the popularity and mainstream, but it turned out to be just another fad. It taught people about joyful, agile frameworks that are highly opinionated and vomit scaffolding. That's Ruby on Rails. And so I didn't like it. I tried, I like the Ruby language more than I liked scaffold vomiting Rails generators. That concept in the Ruby world is called generators. Very different than the generators concept in Python, which are beautiful, elegant, memory efficient ways to parse through, terabytes of data. But in the Ruby world, and I guess the JavaScript world, and Pylons, there's some of it in the Python world, not as much. But you take a framework that is opinionated, and you say, take what you would do with your interpreter or whatever, your opinionated interpreter for your framework, and take the framework out of it by putting out a bunch of files that have everything necessary for a standalone app. Transform your config file based thing into app files, into standalone application files. It's kind of like compiling. You would be like, oh, well, that's like compiling. Well, no, compiling usually makes highly optimized binaries that you just plop into a known memory space and it's running fast. That's an executable. Can't really load it up and look at it. It's not human readable and stuff. But what I'm talking about totally is human readable, and is just a something taken from something that would normally interpret your config files with a framework. That's how these things worked in the days of Hibernate and Cocoon. And instead of doing that, it says, if I were to not have the framework in the picture, and I were instead to generate the code as if I wrote this from scratch, what would that code look like? And that's a code generator, and what it spits out is often called scaffolding. And then you go in and you start customizing that scaffolding, and then you have a work of art. You shape it. And I hate that way of working. I mean, talk about locking into a system, locking into a particular instance. It's just no. I've stayed away from Django on Python for the same reasons. Once your, config files and customizations get too, into the weeds, you've become that kind of person. You've become a Django person. You're now tied to Django. Whereas with Flask, for example, Flask just has these very lightweight assumptions. There's no code generators under Flask. If you want Flask with a code generator, I think that's Pylon. So Flask just says, oh yeah, here's how routing works. It's mostly it. Here's how routing works. WordCraig or something. So it lightly wraps a couple of other packages and says everything else is up to you. So you use your favorite packages and import them and cobble something together. And that cobbled together something is still a one-of-a-kind work of art, but you don't start with a highly customized one-of-a-kind work of art. You start with pip installable libraries. So your knowledge and know-how is transferable between systems, and over the long haul, the long years, you're more obsolescence resistant than if you rely on code vomiters of a framework. Okay, what else? So, I have used many web frameworks over the years. I've developed my own web framework several times over the years, and I am highly opinionated about web frameworks, mostly that I don't want to use them and I don't want to do web development work. I got fatigue. There comes a point where, with a browser as a moving target from a user interface and to a lesser degree an API point of view, the APIs of the browsers change as the JavaScript language matures. And, you can do more, and more third-party libraries are required for you to do more. Very few things other than maybe jQuery capabilities are replaced in the core JavaScript library. A nifty little importing a requirements system. The requirements system is included. And so that, gives you the ability to not include even what a lot of people who are really into these things would consider necessary common parts of the standard distribution. So what I'm saying is the necessary common parts of the standard distribution of, say, well, what is it at these days? It's Node and NPM, the Node package manager. The things that constitute what you can do in JavaScript and server programming are lacking in certain things. Maybe not so much on the server side Node. They must have statefulness there. You don't have to have a package installed to have statefulness on the Node on the server, I don't imagine. But certainly in the browser, well, statefulness is now part of the HTML5 standard. So these things are organically coming together. They're evolving and organically coming together so that you can start to say, manipulating the modern standard DOM object of the browser using JavaScript can give you persistence. You still have the page load issue. The JavaScript is re-executed every time on a page load. Well, the main thing wrong then with the browser is allowing access to the address bar to do things like page loads. Can't you have web apps that just don't have access to that? Yeah, well, Chrome became so popular, Microsoft stole it for their web browser called Edge. Well, if the components of Chrome are that popular that Microsoft will use it for their main web browser, why not use those same components to build non-web apps like VS Code or Slack or a host of other things that are popping onto the scene? The new standalone version of Jupyter Notebook, for example. Well, the answer is no reason why not to. So if you love JavaScript and you want the one language to rule them all, and you want obsolescence resistance in your career, you're probably doing the right thing. Start looking at making standalone apps on Electron. They call that the Electron platform, using the Chrome components to make standalone desktop apps. Methinks there's a lot of life in standalone Chrome, standalone Electron apps using JavaScript. Why JavaScript? Because the consortium that controls browsers say it will only ever be JavaScript and no other languages, although you could totally program for, the Electron platform natively in Python if they just allowed plug-inable languages on the browser platforms, which they don't for some crazy reason. Jupyter is coming around. Jupyter's around allowing any language to get plugged in. I'm really thinking hard now about using JavaScript in Jupyter Lab now on the standalone version, using the whatever pip install just puts it there. It's no big deal now. So I should probably wrap this up. I'm getting close to my destination. I talked about a lot of interesting things, and I guess this became mostly a video about obsolescence proofing in the case, right? It shouldn't be such a long, hard case. It's that, the popular mainstream path now is a vendor trap, right? Microsoft has done it very well. And in a lot of ways, Microsoft and Google, in collaboration, have done it very well. Between the two of them, they kind of got a lock on developers. Some might argue Amazon, but what do you need Amazon for except for generic infrastructure as a service? AWS. Amazon will always be AC at AWS no matter what other services they want to try and layer on. The S3 data store being a great example for that key value type of storage. So many developers out there would think to turn to some web-based, key data store like S3 or Firebase as their first line of defense for data storage. I challenge you to just, from SQLite import SQLite as SQLdict and with SQL dict file name as DB, colon, indent on the next line, you're doing persistent database. You just cut Firebase out of the picture. You just cut Amazon S3 out of the picture. Now, the point is, the danger is, the downside is that it won't scale. You'll get high performance, high local machine performance. When you deploy to the server, all that stuff travels with you, and you'll get per server high performance local SQL-like performance, but not against massive data. It's not going to work against terabytes of data real well, and it doesn't have all that fancy scalability stuff like sharding and the stuff that Mongo does so well. CouchDB, there's a lot of them. There's a lot of things that do this kind of stuff at scale. Redis is used for it a lot. So what? No big deal. No big deal. Okay. Be tuned into your exit. Be tuned into wrapping the video up quickly. No big deal because API compatibility. API compatibility always has gotchas. There is no such thing as full API compatibility, or they'd be the same product. It's one-way API compatibility, for example. Microsoft's favorite trick is one-way API compatibility. Load your files in, do your first save, and you'll never be able to go back to that other product again. That's one of the euphemisms implied by API compatibility, which I'm discovering lately because a lot of you have heard all my talk about Puppeteer over the years, the Python ports of it called Puppeteer over the years. And, I'm on Puppeteer basically. I tried getting on Puppeteer directly natively. That was my path onto JavaScript. But I achieved that state of JavaScript fatigue in record time. And, I hate being forced into JavaScript, but it happens. It happens in your career. Consider it like regex. You're going to be forced into regular expression matching more than once in your career. You just got to bite the bullet and do it. And in fact, get good at it, find the love for it. Early JavaScript books were called JavaScript, the love-worthy parts, which I'm sure greatly guided the ECMA script people to sort of emphasize and expose the good parts of JavaScript more and evolve it in a positive direction. And so you can find the love in almost anything, and I'm trying to find the love in JavaScript. I have on occasion through the years, and it drives me away again just as rapidly. So I was on Puppeteer and then Puppeteer and then Puppeteer again. Now Puppeteer is scary because it's not official, it's not mainstream, it's not from Google or Microsoft. Puppeteer is from Google. Puppeteer is just from random people. Well, those random people have now been absconded with by Microsoft on their standard game plan, on the standard, playbook that Microsoft does, embrace and displace. So, in the same way that they used the Chrome, the free and open source part of the Chrome, code base known as Chromium. If you're ever wondering what the difference between Chromium and Chrome was, the parts that aren't proprietary Google, the parts that they're willing to share back into the free and open source world, are called Chromium. So Microsoft has taken Chromium and used that to create Edge, their Microsoft Edge browser, which is the only browser now in Windows 11. They've purged it, Windows Explorer. Windows Explorer going away. It's now Chrome-based code, Google code, that is now officially the only forever forward default install browser on Windows forever forward. As things change, but you get the idea. Microsoft is doing that again now that Puppeteer has been out for a couple of years. Everyone wants to move off of Selenium, which is terrible. Selenium has all the things wrong with it that I complain about in technologies. Okay, you want to use Selenium, the first thing you have to do is about months worth of specialized knowledge to keep it stable, to run it on a limited set of hardware because it got its dependencies, and to automate questionable browsers. So Chrome was made directly automatable through its own built-in communication protocols. Brilliant move. Google control the browser, give the browser its own API. And that API is too complicated for mere mortals to interact with, so write a local library, a local code library that can simplify it. That's Puppeteer. What's the connection now between JavaScript code on your local machine and automating a browser? Well, you can run JavaScript in the browser, but you can't run JavaScript in the browser to automate the browser. That's a little too meta. That's a little too dangerous. So something outside the browser has to be reaching in and controlling it through those communication ports. I think they call it dev protocol or something. But Node is used for that, a local install of Node. They're like, everyone has Node and local on their machines for full stack web development work anyway, so let's make a package for Node, so that Node can reach out HTTP. It's a web server, but it's so much more. It's like, Nginx. It's a generic component. So Node can do more than just being a web server. So one of the tricks it apparently can do is you can have it reach out with whatever protocol and communicate with things. It's a lot like Nginx being used for caches and stuff. So there's really a lot of interesting tricks that are being done with the Node. And this is one of them, a local copy of Node on your local machine running JavaScript from the Puppeteer library will automate Chrome. Okay, so this was a game changer because it provided a lot of things that Selenium did not. Speed, lightweight overhead, not a lot installed. You might say, oh, it requires a Node and a Node package installed through NPM, so you need NPM as well. Even after all that, it's still not as heavyweight as what Selenium is doing. And so it's faster. It's also more reliable. Things go wrong in Selenium. It's like, what are you automating? There's all these weird things. It's been over the years. It's been, Chrome driver.exe, not the real Chrome, never the real Chrome. I don't even know if to this day it is. This is one of the kind of reasons, the Puppeteer and Microsoft port of Puppeteer, which is what I'm going with this, is taking us. Oh, that name, boy, Playwright, Playwright, Playwright. So Microsoft ported Puppeteer and created Playwright to automate browsers, just like Microsoft used the Chromium, the Chrome free and open source code to create Edge to be their browser. So of course they have their own browser now. They've got new testing needs. They look around for testing. They see Puppeteer. They're like, oh, well, this will do it. But it doesn't do it for everything we need. Oh, well, we need to develop our own. Well, who knows how to do this stuff? Oh, the people who created Puppeteer. Well, let's just get them, incentivize them, however, to work on Playwright. So Puppeteer lost its lead developers to Microsoft's Playwright project, which is a fork of Puppeteer that adds to the mix, not just, it's the easy pickings. What do you do to make this more embraced? Well, you make it automate more things than just Chrome. Oh, well, let's make it work with Safari and Firefox. Okay, done. Already, it's a better library. People who haven't wrapped their mind around asynchronous and never will, we should make it appeal to the, oh yeah, okay, so you don't have to use the async await keywords. You can, you just browse a linear sequence of commands, right? Browser automation. You don't need asynchronous for that. Okay, let's give those people an API that does not force you to use asynchronous mode. Okay, so right there they simplified it a lot. But wait, there's more. Oh yeah, everyone who wants to control this stuff with Python, as everyone really does. If anyone in this sort of script file testing world, tells you that their primary language choice is JavaScript, they're lying. All the main tools out there for doing Metasploit, this kind of stuff, is Python libraries. They're not JavaScript libraries. Python has been in this sort of network systems automation testing world. Just pick up an Alt 2600 and flip through the pages and you'll see. So whereas people like me who are stuck on Puppeteer is going away, it's losing its leads. Original developer disappeared. There's another version. Should we use that? When's the last Git commit? Microsoft made Playwright natively also Python. Not being forced into asynchronous mode, providing a native Python library as a first-class library of the automation package. Providing, did I already say non-synchronous mode, so you can code it a lot more easily, and then throwing in goodies here and there for discovery of the most clickable paths on the page, because dealing with CSS selectors and XPath is horrible, especially on React.js generated code. Oh my God, I've never seen uglier code on the back end. And harder code to automate against. Maybe that's by design, but there you go. Not an IDE to sink your teeth into. So Microsoft, as part of Playwright, throws in a few extra goodies to show you the most commonly likely to be used paths for interacting with a page. I think there's like REPL environments, read, eval, print loops, but in this context, what it means is the ongoing ability to inspect the state of an open browser and to send it commands and to make it move stuff without it being on the actual run. So most of us think as browser automation, run, and then it'll move and make the browser do your things, and if you made a mistake, you have to make a little adjustment and then run it again from the start. That is not the case anymore in this Jupyter Notebook, Jupyter Lab world we're in, because your code never stops running. And through some magic, I'm going to have to research this and document it, the main event loop is managed well under Jupyter Lab today, which means things that are running, even in asynchronous mode, it doesn't matter. They can just keep and stay running while you go and you inspect something over here, and then you send new commands to it on a line-by-line basis. You say, oh, okay, now click this button. Okay, now toggle that. Okay, now scroll that. And then you can even use all these great tools to record and play back. So you go, when I do that, it generates this code. Okay, I can copy and paste that into my instructions here. And so you can do this, mixture of having a line-by-line executable, re-executable REPL, they call it REPL environment of Jupyter Lab and notebooks, to interactively control the browser, plus these supporting tools like browser plugins and these Microsoft tools to tell you the common paths being used, and the ability to inspect the object in real time, especially through the code inspector built into the into Chrome. And it's wonderful as we're in a new age of Chrome automation, and that's kind of where I was going with a lot of this. I'm switching to Playwright, and I'm going down the one-way Microsoft path. So I got to wrap up there. Time to pick up my kid. Thanks for joining me. Hope to see you again soon. Don't forget to subscribe.